Today's notes are 5-5 day 1, so we are solving inequalities in one variable. So what we're going to do first is just compare these numbers. So please take a few minutes to compare the following numbers. You're going to express the relationship to each of the problems using the symbols greater than, less than, or equal to. All right, at this point, we should have had time to go through all of these. So obviously, number one, it is greater than, less than, right? And then the bottom is taken a little trickier, right? Ones that are bigger are the ones closer to zero. So negative 1.3 is closer to zero, so that is greater. On the next one, if you reduce 4/8, it actually is 1/2, which means that these are equal. And on the last one, I would calculate those first. So if you do that, 3 divided by 5 is 0.6, and 4 divided by 7 is but 0.5714 dot dot dot. It keeps going. All right. And it does eventually stop, but it keeps going for a little bit. So obviously the 0.6 is greater, so it would be a greater than. The next part I encourage you to try to do on your own as well. So take a second and figure out which ones you think go with what, and then we'll talk about it. All right, so when you're going through these, okay, the big one, I mean, less than we know is this one. Okay, what I think of is if you kind of extend that out, it kind of looks like an uppercase L. So that's the less than. More than is the same thing as greater than, right? Now, when it says up to, that means that whatever it is going to be the highest, and you're talking about everything below, so that would be a less than. At most, so similar to up to, at most is saying it needs to be less than or equal to that number. So at least would be the other way around. You're talking about that number and then anything above it. Now, when you do between, there are two different ways that we could talk about this, right? It's going to be between numbers. So if you have like 0 to 10, right? X would be less than 10, but greater than 0, okay? Or 0 is less than X, which is less than 10. You could write it the other way. So 10 is greater than X, which is greater than 0. I'm going to typically write it this way. And that's not one I expected you to know right now. We'll use that in the next couple sections. Obviously, greater than, fewer than is the same thing as less than. We have less than or equal to. No less than, so that means it needs to be greater than, which is the same thing as this one. And no more than, similar to no less than, it's saying everything under it. Okay, so now here are the two big parts. We're talking about set notation and interval notation. Okay, set notation is very specific. Okay, so you're going to have these little squiggles. All right, you need to learn how to do them. I'm fine if you just do it like this, but it's not a parenthesis. Okay, I forgot what that's called. I'm going to figure it out. I'll tell you in person. So you do that, and then you do your variable, and then a line. Okay, and that line means such that, and then you're going to put your inequality. Okay, so it's going to look like this. You're going to have your squiggles, x such that x is greater than 3. Okay, that is set notation. Interval notation has some specific things. Okay, you're going to use parentheses or you're going to use brackets. Okay, and it might be a combination of both. But parentheses are used when it's not included, which also goes with an open circle. It's kind of like you cut that circle in half and you have the two pieces. Brackets are going to be when they are included, which is when you're talking about a closed circle. So examples of this would be like it goes from 3 to 10. So that's saying that you could be 3 and you could be all the way to 10, but you can't actually be 10 because it's not included. So it would be less than 10, but greater than, okay? If we went to the one above, like if we wanted to be the same as the one above, x is greater than 3, that means 3 would be included and it would go to infinity because it would be everything above it. So let's get into using this set notation, right? So if we're looking at A, B, and C, I encourage you to pause and write the inequality for those really quick. So if you're able to write those inequalities, it'll help with our interval and set notation. So this ends up being x greater than 4. Notice how it's not greater than or equal to because it's not included, which is something we could add up here. Ones that are not included, these open circles are either less than or greater than, whereas these are equal to because they're included. So it's greater than 4. So if we look at our set notation, which is the bottom one, that means that we would such that, and then we write that inequality, x is greater than 4. Our interval notation is a little bit, we keep thinking about from left to right. So our farthest left that we're going to talk about is going to be 4. Now it's going to have a parenthesis because it's an open circle. And our farthest right is going to end up being infinity. We're just going to keep going on forever. And infinity always has parentheses. Okay? Negative infinity or infinity always parentheses. Okay? All right, let's look at letter B. Hopefully we were able to say, okay, x is greater than or equal to negative 3 because it's a closed circle. So that makes set notation easy. X such that x is greater than or equal to negative 30. So on letter B, we think farthest to the left. Well, that one's negative 30, and it's going to be a bracket because it's a closed circle. And then you go farthest to the right, which goes on forever, which is infinity. On letter C, this one is going to be x is less than or equal to 43 because we're talking about everything below it. So that means our set notation is x such that x is less than or equal to 43. And then from there, our interval notation. Okay, we're starting from the left. So if we go all the way to the left, that's negative infinity. And then to our right would be 43. And that 43 is a closed circle, so it is a bracket. Now, one thing that does happen every time, as long as your variable's first, whatever your arrow is going to be your inequality. So it goes towards this arrow, so it goes towards this arrow, so it goes this way. Okay, it's a nice little trick. But your variable has to be first. All right, so on this next part, we are going to just kind of put together the different things in the chart. Okay, so if we look at letter A, for letter A, x is less than 5. That means that we are going to put 5 somewhere, and then we're going to put an open circle because it is not equal. Well, it is less than, which matches this side, right? So it should all the way to the left. So now set notation, nice and easy. We put x such that x is less than 5. Interval notation, start with the left. All the way to the left is negative infinity. All the way to the right is our number, which is 5. And that's a parenthesis because it is not included. On the next one, we have a closed circle at 5/9, and then it's shaded to the left. If it's shaded to the left, that means that that is less than 5/9. X is less than 5/9. Now this one is or equals to because it's a closed circle. So we kind of copy that over in our set notation. X such that x is less than or equal to 5/9. Farthest to the left in our interval notation is negative infinity. And then we go all the way to our 5/9. which is going to be a bracket because it's included. On our next one, we have just the set notation. So I know I can copy that over to my inequality. So this ends up being just about the same thing, right? It's almost the same as the blue. The only difference that's going to happen is that it's going to be an open circle because it is not equal. We're shade over here. All the way to the left is negative infinity. All the way to the right is 5/9, and it is a parenthesis. When it comes to graphing, you can do it differently. The way that I have it drawn on here is my most preferred way, but you can just look in the black over here. You could just have it above it if that makes more sense to you. And our very last one is one of the harder ones. We have negative infinity to 6. Okay, so if you think about this on a number line, we know we're going to have 6. So then I think, okay, this is a parenthesis over here. That means it's going to be open. And we need to go towards negative infinity, which would be to the left. Okay, so that ends up being our graph here. So because it's going towards negative infinity, that means x is going to be less than 6. It's going to be just less than, not less than or equal to, because it's the open circle. And we can copy that down over here. The last two that we're going to do today is just a little bit of solving. So we're going to solve it and then we're going to graph it. On the first one, if you add 5 to both sides, you're left with x is less than or equal to 15. So we plot 15. It's going to be a closed circle because it is equal to, and less than is to the left. So based off of that, I can write my interval and set notation. Well, set notation is the same as what I wrote. X such that x is less than or equal to 15. An interval notation, our farthest left is negative infinity. Farthest right is 15. And it is a bracket because it's included. For letter B, we would add 12. And we get 20 is greater than or equal to x. Now, it's very difficult to know which way to shade when our variable isn't first. So what I would do is flip it so that x is first, the 20 is second. But when you do that, you have to flip your inequality. And what I think about it is on this one, it's opening towards 20. So it needs to continue opening towards 20 in the second one. So now we have x is less than or equal to 20. So we would have a closed circle shaded to the left. Our set notation is x such that x is less than or equal to 20. And our interval would be negative infinity to 20 with a bracket.